Have you ever wondered if there's another version of you out there living a completely different life in a parallel universe? What if every decision you've ever made has spawned an alternate reality where you took the other path? Imagine a universe where you became an astronaut, a world-renowned chef, or even the president. But is this just the stuff of science fiction? Or could there be some scientific basis to these fantastical ideas? And if these parallel universes do exist, could we ever visit them and meet our alternate selves? The multiverse hypothesis. The concept of a multiverse is fascinating, but what exactly is it? Simply put, the theory suggests that our universe, vast as it is with its hundreds of billions of galaxies and almost countless stars, may not be the only one out there. Imagine an entirely different universe, separated from ours by unimaginable distances, or even different dimensions. Now, go a step further and think of not just one or two, but an infinite number of such universes. But how did we arrive at this mind-bending concept, and what theories support it? The multiverse hypothesis has undergone significant transformations over the years. Initially, it was more of a philosophical notion, a way to explain the mysteries of existence and the universe. However, as scientific inquiry progressed, the idea began to take on a more empirical form. And despite the lack of concrete evidence, the multiverse hypothesis has gained traction in recent years, thanks in part to proponents like Max Tegmark and Brian Greene. These physicists have proposed various classification schemes for multiverses, diving deep into different dimensions of space, physical laws, and mathematical structures. Types of multiverses. Number 1. The infinite space theory. In the vast expanse of the cosmos, the universe we observe is just a minuscule patch in a potentially infinite cosmic quilt. The sheer size of the space is mind-boggling. With hundreds of billions, if not trillions, of galaxies spiraling through space, each containing billions or trillions of stars, the universe's magnitude is beyond human comprehension. Some scientists speculate that the universe's diameter could span 7 billion light-years, while others believe it could be infinite. If space truly is infinite, then the implications are staggering. Every conceivable event, every possible configuration of matter, would occur not just once, but an infinite number of times. This means that somewhere out there, there could be another version of you, living a life that's slightly different or even radically different from yours. The idea isn't just a figment of science fiction, it's a logical consequence of an infinite universe. If you travel far enough, you might encounter regions of space identical to ours or nearly identical but with subtle variations. However, this theory also raises philosophical questions. If there's an alternate version of you out there, what does it mean for your sense of self? Are you unique or just one of countless versions scattered across the infinite cosmos? And if the universe began at a specific point in time, as most physicists believe, then the likelihood of an exact duplicate of yours diminishes. But the sheer vastness of space means that even if the odds are astronomically low, the possibility still exists. Number 2. The inflationary multiverse. The universe's origin story, as told by the Big Bang Theory, is a tale of explosive growth. Roughly 13.7 billion years ago, everything we know existed as a singularity, an infinitely small and dense point. Then, in a fraction of a second, it expanded faster than the speed of light in a process called cosmic inflation. This rapid inflation stretched the fabric of space-time, setting the stage for the universe's subsequent expansion and the formation of galaxies, stars, and planets. But what if our universe is just one of many bubbles that formed during this inflationary period? Theoretical physicist Alexander Vilenkin suggests that this inflation didn't end uniformly. While it ceased for the observable universe, it continues elsewhere, giving birth to bubble universes that are forever out of reach, expanding faster than the speed of light, making them impossible to visit or observe. The implications of this theory are profound. Each bubble universe could have different physical constants and conditions. Some might be hospitable to life, while others might be barren and hostile. The vast diversity of these universes could explain why our universe seems fine-tuned for life. Out of countless bubbles, we just happen to be in one where the conditions are right for our existence. Number 3. The quantum multiverse. Next up, quantum mechanics, the science of the very small, introduces a radically different kind of multiverse. At the quantum level, particles don't have definite states but exist in a superposition of all possible states simultaneously. It's only when we observe them that they seem to choose a state. The many worlds interpretation of quantum mechanics suggests that every time a quantum event has multiple possible outcomes, the universe splits, creating a separate reality for each outcome. Imagine flipping a quantum coin. In our universe, it lands heads up. But at the moment of the flip, another universe branches off where the coin lands tails up. This process of branching happens countless times every second, leading to an unimaginably vast multiverse of alternate realities. In some cases, the differences might be minuscule, while in others, the divergence could lead to entirely different histories. Number 4. The brain multiverse. Lastly, string theory, a framework that describes the fundamental forces and particles of the universe in terms of tiny, vibrating strings, introduces the concept of brains. These are multi-dimensional objects that exist in higher dimensional space. Our universe might be a three-dimensional brain floating in this higher dimensional expanse. And there could be other brains, each representing a separate universe floating nearby. These brain universes could be radically different from ours. They might have different dimensions, different types of particles, and different physical laws. The interactions between these brains could give rise to some of the phenomena we observe, like the mysterious dark matter and dark energy that seem to make up most of our universe's mass and energy. The brain multiverse theory is still in its infancy, and much remains to be understood. But it offers a tantalizing possibility that our universe is just one of many, floating like a leaf on the surface of a vast cosmic pond. Now let's ponder the million-dollar question. Can you pack your bags and hop into another universe to see what alternate you is up to? According to current scientific theories and interpretations, the answer leans towards a disappointing no. But let's explore why that is. In the realm of quantum physics, the many worlds interpretation suggests that every decision we make creates a new universe. For example, if you decide to have coffee instead of tea, another universe is created where you choose tea. We already saw how this idea is rooted in Erwin Schrödinger's quantum wave function, which posits that particles exist in a superposition of states until measured. Once measured, the wave function collapses into a single state. However, Hugh Everett, who introduced the many worlds interpretation in 1955, argued that the wave function doesn't actually collapse. Instead, all possible outcomes happen, but we are only aware of the ones we experience. The other outcomes branch off into different timelines. While this theory suggests that new universes are being created all the time, it also implies that we can't visit them. Physicists like Sean Carroll assert that we'll never know or experience these other timelines. However, David Deutsch, a proponent of the many worlds theory, hopes that future quantum computers might be able to detect these divergent timelines. Then there are also the limitations posed by the eternal inflation theory. The idea is that the bubble universes are expanding at the speed of light. Thus, they are moving so far away from us that we are unlikely to ever encounter them. Even if we could, the laws of physics in these universes might be so different that they could be uninhabitable or even collapse upon themselves. So, while we may not be able to visit these parallel universes right now, pondering the possibilities they offer expands the horizons of our imagination and scientific inquiry. After all, that's what makes it so exciting, right? Until science can tell us more about these big mysteries, we can use our imagination to think about what could be out there. If you liked the video, please consider subscribing and sharing so we can keep bringing more content like this. See you next time.